Everybody ready? Everybody got the beer? Yeah, okay. So, yeah, let's start then. Good to start, Hamza?
Yes.
Yeah? Okay, I think we have some hardware.
Do some magic
Wait.
now.
Magic? No, I don't know how to make.
Questions again?
Let's see if there is a a rabbit here from my. No, there's no. Yeah, I should have prepared for magic. I didn't know. Okay, so without magic, let's start. So again, thanks for coming. So who here was on the last month in the previous meetup? Okay, so kind of have. So welcome the new people to the group. It's the second time we're meeting. I hope to see you again next time. So for those that were here last month, maybe unfortunately, like I'll bore you again for the second time. On the first time, I talk about some of the things that I really like about Go, and I think it served. I hope it served as an introduction, like general, like set of features. And my list is a bit longer, so there are other items that I wanted to talk about, and this is what we'll do today, is just follow up on the previous talk. So for those that missed or those that were here, a reminder, we talk about simplicity. That was by far the most interesting thing about Go, is the lack of features. Then single dispatch, capitalization, Go format, Go doc, no exceptions, table-driven tests, and interfaces. So let's start with the next topic. So for me, what is really interesting about Go is that Go has first-class functions. And what does that mean? It means that functions in Go, they can be passed as variables, they can be returned as values, and so on. So it's a very simple thing. Like if you're coming from a language like Python, like I was, or Ruby, you just think like, you don't even think about this. You just take it for granted. But unfortunately, like in the recent months, I had to write a lot of bash code, and like it really sucks that you cannot express things like as functions and like pass them around. So when I go back and look at Go, I think, yeah, like this is trivial, but it's really like awesome. So maybe on top of that, let me move the pointer away. Okay, so maybe on top of that, which is different than other languages, the cool thing about functions, that they are just regular values in the language. You can even assign methods to functions, right? So here is something from the standard library. We have a type handler func, which is just a function signature, right? And you can actually declare a method on top of that and use it. Just like a lot of people come to Go and they think about structs as classes, and there are no classes. It's just like types, and you can put methods on types. So like this, since this is something very trivial, I try to find like one use case where this appears like in regular code. So I have here some code that is basically calling out to like executing a process, in this case running bash with some stupid thing. And the use here of the fact that I can pass functions around is that I can pass just an inline function here to another function. So there is this function time after func that it takes a timeout. So basically saying like after 5 seconds, kill the process that I'm running. And I do this by passing a function. So here you could also think about that this function is capturing a variable that is in the scope. So this is a closure. There are a bunch of things to talk about here. So it's very cool that you can like create this sort of thing. I will just show you like running. I have to come here and click. Like if I run this program, I do just like these first lines, they're coming straight from my date command, right? And just printing the date. And then after 5 seconds, the process gets killed, right? So that's just it. So let's move on to the next thing. Like there are a lot of things, like I want to kind of just give a brief overview over them. Some of them are more interesting, some of them are less. So later on, like you may ask questions and we may talk a bit further about some of them. So the next thing is fully qualified imports. So this is just how the header of like the beginning of a Go file look like. Right? You have a package declaration, and then you import a lot of things that you use in your file. And like what I like about this is that it's really easy to tell where something's coming from, right? So you can see here like all these parts, all these names in the beginning, they refer to the standard library. It's just like a normal name, right? Like, or maybe not so normal, like FMT, IO, IOU2, OS, time. And then there are these other things that they look like URLs. And like you open some random file and you kind of, it's easy to tell like where you're gonna find the definition, like the source code of these things. You just like copy this into your browser and press enter, and that's it. So comparing with another language, like I took, so this code, the first code I showed is something from OpenShift, the project I work on. And I just took something from a previous version of OpenShift, which was implemented in Ruby. And I found a file that looked like this. There are a bunch of requires. And they do say like OpenShift, so you kind of know that this is not the standard library, most likely. But it's hard to tell like what is from the standard library, what is not. And for what is not, like where are these things coming from? So obviously, like we need a way to determine where this is coming from. So you have things like gem file, or like in Python you have something similar. You need like like there is an index of packages somewhere in the internet that everybody agrees to use. So you go with a name, and then it finds the source code. But I like that in Go, like it's easy to make this mapping between like the thing you see in the source code and like where the thing probably lives. So yeah, so what is there like for imports in Go? They are just plain strings, which gives a lot of flexibility to the language specification. So I just took this straight from the language spec that says that the interpretation of the import path, that string that we saw there on the import statement, it's implementation dependent. But it's typically a substring of the full file name of the compiled package and may be relative to a repository of installed package, blah, blah, blah. So basically what it means is that it's normally something, is a relative path to the only configuration you need to do in Go, which is set your environment variable called Go path. You just say like where a code is going to live, and then like you just structure, the code is structured with normal like directories as you would do, like you just use the file system. And normally by convention, the package name, so I'll go back, here we have like, the package name is normally the last part of this big string, right? So if you have a path here, which is GitHub, Docker, builder, parser, this will be by default package parser. Or you can say, hey, I want to give another name to this. Like I don't want to call it API, I will call it KAPI. Yeah, so the cool thing about the imports resembling URLs is that it allows you to create tools that go and download source code for you. So a lot of people love like the fact that you can just do like go get and download and install like all the source code for a certain program. This is pretty cool, but then people normally go like very happy about it, and they think it's gonna solve all the problems. It doesn't. So there is a little note here that even though like this is cool and allows you to do certain things, it will not solve problems with versioning and like dependencies, what version of your package depends on what version of what. And there are a lot of people that complains about this in Go. So just a note that, yeah, like this doesn't do magic. But I would focus on the good part, is that again, given the import on the file, you can easily find, like, figure out where it is, even in your hard disk or on the internet. So next one is static typing with type inference. So who here is working on a dynamic language like Python, Ruby? Yeah, like primarily, yeah. So I was also working with Python for a lot of time, but I started to miss sometimes like being able to let the compiler or let something like a compiler type check the code for me. So other languages like, I don't know, Java or C++, like something that you may have used that have static types, it's normally like a bit frustrating, at least for me. I don't know if you share the feeling that you have to write things about the type like over and over. Like, okay, it could be a bit smarter, right? And I see that new languages. I remember like Swift. I don't remember. Like, I think there are several languages on the JVM platform and Go. They have this thing called the type inference, which is basically it allows you to don't write the types a lot of times, and the compiler will infer the type for you. So I have an example here. Basically, I think this is how we would write a lot of times. This is similar to the previous code we showed. I'm just declaring a variable. I say it's CMD, and I say that I'm calling a function here with arguments, and whatever is the return value of this function is obviously the type of the variable I'm just declaring, right? So I don't have to talk about types here. So you normally write this piece of code, and I think this is pretty cool. It feels like you're writing Python, you're writing Ruby. But you have the type system there for you to tell you if you messed up with types. So if you're doing like refactor and changing like functions, signatures, and so on, this can help you. Like the type system can help you. But like I have other like variants here just to explain like how you could actually be more explicit about the types if you needed to. So this syntax here is a shortcut so that you just say the name and some expression. You could say like I'm declaring a variable, so you say var and then the name and then something. Or you could say the name of the variable and then the type, but this is already like here is unnecessary, right? It's superfluous information. Compiler can get it for us. Or you could do like sometimes this is valid. You just say, hey, I want this variable here CMD, and I know the type it is, but I don't know yet. I don't want to initialize it yet. So you may do this and then initialize it later. Not in this case. This is just like, just to show that this is possible. But a lot of times you just write this, so the code feels very like simple, right? Very lightweight. So another point is about speed. So a lot of people come to Go. They think that their current language is slow, and they want a faster language for whatever reason. So for me, there are at least like 3 things about speed. One is to talk about the speed of development, so how productive you are with the language. Then speed of compilation for compiled languages, of course, and execution time. So it's interesting. Like there is a talk from Rob Pike, one of the authors of the language, about like why like simplicity is the key in the language. I really recommend you watch that. And he points it out that this like the fact that people say, oh, it's fast, is just a superficial reason to like Go, right? And I agree. Like I just left the link here, so later on you can catch the slides and follow it. So what I really like about Go in terms of speed is that normally it feels like a scripting language. Like you could just write code, so the development speed is pretty good, right? You because of other things like the type inference, right? Like you write things, they are short and obvious most of the time. So your productivity as a developer can be pretty good once you're comfortable with the language. There is very minimal boilerplate. So the language was designed so that you don't need XML configuration files, make files, and some other like configuration around. Like you just put files. Like the only thing you have to configure is the Go path, as I mentioned, right? You just put your code in the right place, in the convention place, and like you use the standard build tool, and it should just work. Of course, it's like it doesn't have to be like that, right? So just to give like an idea, like if you have like a project gigantic like OpenShift, it can take like several minutes, like 5 minutes to build from scratch, right? Which is it makes me feel terrible and like I don't know what to do, and I'm like, okay, what do I do with 5 minutes, right? It's crazy. But then, like, I was talking with other people, and they are working on a Java code. They said 5 minutes. Come on, like my build time takes 30 minutes, hours, and like, okay, so, but it's still like pain in the ass for me. You see here, like I have a hello world in Go just to show you like how it really feels. I showed the other example, and you see here that developing is most of the time just this, right? You click and it just works. You want to run a unit test, like you just tell it to run and it just works like immediately, right? So yeah, good that Brno arrived. I have a friend there that like we were chatting yesterday, and I thought that yeah, because of him, I need to put some graph in the presentation. And you know when that's the moment there is a presentation, there's some random graph you don't understand, you're afraid to say it, and like you think you're an idiot, but you're not. It's just that the graph is completely random, right? So I thought I would do this the same, right? Just why not? So what I wanted to tell here is about like how the speed of Go improved, like how it changed over time, right? And yeah, basically Go, like since the 1.0 release, like we are now on 1.0, so now we are on 1.6. So there's been like several releases, and up to Go 1.4, the runtime was mostly implemented in C, and it was like pretty fast, right? It was pretty nice. You could compile OpenShift in 40 seconds. And then with Go 1.5, they changed it to, they like rewrote automatically like gigantic portion of everything into Go. So what they're able to do is now like everything is written in Go. They can like make further optimizations and so on. But of course, like the speed like skyrocketed, and like Go 1.5 is crazy slow. For a hello world, you don't care about it. Like it just works as before. But for a huge project, like linking time in OpenShift takes forever for me. Like you know, you don't get that feeling of it just works like a scripted language anymore. The good news is that it improved a bit with 1.6, and it's improving again significantly with 1.7, which is the upcoming release. So 1.7, I think it wants to get back to the 1.4 performance, but again, they're making a lot of improvements, and certainly like for a lot of programs, the runtime has improved a lot. So I think, and compare, of course, I compare to what you're thinking about, like other languages, it's still like rocks. So yeah, so let's go to the next thing. So metaprogramming. Metaprogramming is, you can think about it like in several different ways. So I just took a definition from Wikipedia to help us. And one of the ways to think about it is the ability of a program to write another programs, to be short. And like, whenever I think about this, it makes me think about Lisp. So who here has played around with some Lisp-like languages, like those parentheses, so Scheme or Lisp or Racket? Yeah, so there's a few crazy people. Cool. So yeah, this talk is not about Lisp, but the idea, like the cool thing about Lisp is that there's basically no syntax. It's just parentheses, some word, and parentheses, and then that's it. Right? I talked about the whole, like, everything there is to say about the syntax of Lisp languages. And the cool thing is that it's very easy to write programs that write themselves. Like the language, it's something called like some hard word to say. I have to read it probably. But yeah, it's just that the representation of a program is represented like in the language itself. So you don't need another language to write programs. So if you're coming from C, you have like these macros, right? So you have like a separate language to work with C. And with Go, like, yeah, it doesn't have generics, like as a lot of people complain, so you cannot write a max and min function that works on floats and integers all at the same time. Yeah, you can't. There are no macros like Lisp or like this preprocessor macros like C. But it has a lot of things that let you write programs that write programs. So that's, for me, a valid way of doing metaprogramming. So one of the things is the reflect package. which lets you do obviously reflection on runtime. Don't overuse it. Second thing is, well, there are actually, like if you follow the links here, there are a bunch of packages in the standard library that help you with parsing source code. Then you can do type checking, and you can like change the abstract syntax tree, like move things around. You can easily like make programs that rewrite the programs in some programmable way, right? So for me, this is pretty neat. And there are a lot of examples that like you don't have to, boom, like just come with everything from your head. You can just look at existing programs that do just that. Like they take programs as input, they write transform programs. So there is this Go thumpt I mentioned last time that formats Go code. There are Go imports that is the same as the previous one, but it automatically add or remove imports and reorganize them. There's a stringer which generates code to implement string methods on certain types. So this is like completely different, right? Like it takes as input some information and it outputs like an automatic program. Within OpenShift, we also have like a lot of code generation scripts that they're based on this tooling, these libraries, and like we just, for example, we need to copy complex structures. So if you have like a structure that contains other structures and so on, there might be pointers around, and there might be like, you can't just like, there's no deep copy function built in. Like you can't say, hey, I have this complex thing in memory, give me a copy of it. So what we do is we generate code that can do this with other code, right? So it is the meta thing. And I think this was added in Go 1.4. I'm not sure if somebody can remind me. There was the addition of this Go generate tool, which really allows you to, for example, if you use it, one of the examples together with stringer, it lets you write a comment on a source file. So again, there's this idea that you don't want to have like configuration files and a bunch of stuff, right? So you write a comment on some source file, and then you run Go generate, and it can automatically execute some instructions that were in that comment line. And this is normally used for generating code, right? So you want to say like Go generate and like run some program that generates code for you when you commit in your source repository. So we are past the half of it. So static linking. So the next two things they're quite related. So with static linking, it's just to say that like when you have an interpreted language, maybe you just like handle with source code, right? Text files. When you're doing like some other, maybe you're doing C, like, and you have to choose if you do like a static linking or dynamic linking, so that you have to choose if your program is like just your code and it depends on things installed on the user's computer later on, or if you pack everything together at once. And Go by default do this last one, right? It just creates static binaries for you. And what I like about this is that it's really easy to deploy and distribute programs. So there is like one perhaps downside to think about is that you can have a very big binaries. So just like I looked, just not today, maybe yesterday, like the size of the OpenShift binary, which contains like everything, it's 134 megabytes. So that's like it's a Linux distribution, right? Like in one binary. But yeah, it really does have like a bunch of things inside. And yeah, so I really like that. Like the more like I think about it, it's very straightforward to distribute programs. When we combine this with the next thing, you see how like it makes it great. And the story I have is about distributing Python programs. That back in university, I was doing a program as a chat client for blind people, and it was written in Python. And basically, I needed to distribute this to Windows users. and it was a pain, right? Because I cannot ask the users to install like Python and copy my script somewhere. So at the time I used some tooling for Python. It was, I think, PyInstaller, but to produce an executable with everything inside. But it's really a pain. Like the language is not meant to be used like that. And with Go, it just works, right? Like you can just compile a binary, send it over email to your friend, and he can use your program. For me, that's pretty cool. So combined with that is cross-compilation. So we had a workshop today about this earlier, and it's pretty awesome. With Go, you just set some environment variables, and you can cross-compile code to a number of different operating systems and architectures. So I'll not go into details. I'll just show. Great. So it happened last time. I was aware of this, so don't worry. Yeah. So this is just like how you can use that. So I had some this func Go is one of the examples I showed. Wow, no, this doesn't work. Yeah. So I'm just like running Go build with different environment variables, so I can change Go operating system architecture and build different output into different files, and it generates. Great. So let's begin. Welcome. Let's start. Yeah. Yeah, I'll stop using this. I think it had enough of me. So as you can see, it's pretty trivial. Just changing environment variables, you can build for different architectures and operating systems, no matter where you are. You can be on a Windows machine, you can be on a Linux machine. It will just work the same. We need a new one next time. Okay. So the last thing I want to mention is about Go proverbs. So one of the things I really liked in Python was this. So maybe this is not a feature, right? It's kind of a philosophical discussion we start to have. So that's why this is the last one, and I'll leave. I promise. So there's this thing called Zen of Python. Who here has heard of this? All right. So I think most people, if you've done Python, this is one of the things that eventually you get into, and this is basically just some poetry that guides you with things that you should do or you shouldn't do. Right? And it kind of gives some idea of what is idiomatic in the language, what is not. And with Go, we kind of recently, I think a year ago maybe, we have something very similar, which is called the Go proverbs. I discovered that for the game of Go, there is also something called Go proverbs. That's why it's called like that. It's basically a bunch of sentences that express some idea, and I would just list them. I'll not go through them in detail. It would take another 5 hours. I think I don't want to do that, right? So I'll just show you what they are, and you can think for yourself what they might mean or not. So the proverbs go like this: don't communicate by sharing memory by communicating. So we haven't talked about concurrency, but that's one more of the very highly, everybody is happy about the concurrency features in Go. Concurrency is not parallelism. Channels orchestrate, mutex serialize. The bigger the interface, the weaker the abstraction. We talked about this last time. Make the zero value useful. The empty interface says nothing. Go font style is no one's favorite, yet it's everyone's favorite. We also mentioned this last time, just the fact that the language has a standard style and you can run a program to enforce that, you just stop complaining about random spaces or different ways of formatting code. A little copying is better than a little dependency. Who here has seen the not so far episode with Node and somebody deleting code from internet? Yeah. So a syscall must always be guarded with build tags. Cgo must always be guarded with build tags. So these things are specific to the language, right? Cgo is not Go. Yeah, it has a C in front of it, obviously. With the unsafe package, there are no guarantees. Yeah, it's unsafe. Clear is better than clever. Reflection is never clear. Errors are values. Don't just check errors. Handle them gracefully. Design the architecture. Name the components. Document the details. Documentations for users. Don't panic. The good way to understand these things is to go with Rob's presentation. There's the link in the beginning in the slides, so that's where you get to understand like what these things mean. So just to recap, we've gone through today was we talk about first-class functions, again, trivial thing, but I love that Go has it. Fully qualified imports, you can tell where things are coming from. Static typing with type inference, very good speed. Metaprogramming, static linking, cross-compilation that I think together are great for distributing your programs. And the Go proverbs, which gives this spiritual guidance for like what to do and what not to do when you're coding Go. Yeah, with that, I don't know if I have time for questions. I don't know where is Hamza, yeah. So I have time for questions, so yeah, if you have any questions. Yeah.
Can you go back to those proverbs that explain those build tags?
Okay, so where were they? This was the last one, right? See, Go must always be guarded with build tags. So there's this. So Go, there's no configuration files, but there are actually a lot of magical comments. So you put comments in your source code, and it has some special meaning. So one of the things I mentioned was this Go generate. So you write a comment with Go generate, and it will be like taken into consideration by Go generate tool. For the Go build tool, when you run Go build, if you have a comment that says build, and then I think it's like plus build and then some name, the file in question, it will only be built if you pass that tag for Go build invocation. So it's basically a way to filter what things are considered to build and what things are not considered to build. And the thing here is that like when you're using CGO, it lets you like call C code. It's not necessarily cross platform or like. So you may want to limit this to certain conditions, right? So the build tags allow you to do that. It says, hey, like this file here only builds if the tag like build with CGO is set. So you need to run Go build with that flag, and then the file will take into consideration, otherwise it won't. Yeah. Something else? Yep. Incremental compilation. Yeah, so, well, maybe somebody will have like a better answer. So basically, do we have incremental compilation? I don't know if that can be called incremental compilation, but when you build something, it's automatically cached. Like the way the Go path works, you have source code in one directory, then you have everything that is built under the package directory or bin directory. And so you build something for the first time, it will create a lot of the .a files, archive files with the compiled code for each package, and then it just links things together. If you're building a binary, right, it just links things together. So if you change something, it won't go recompile everything. It will just recompile what changed. So if you consider that like incremental build, then yes, it does have it. But I don't know if there is some like better technical definition for what is or not incremental build. So does somebody have a comment on that, or does that answer the question? Yeah. So, yeah, so not just the build times are quick, but when you, of course, like rebuild a big project again, you don't rebuild everything, it's just the things that changed. So maybe somebody wants to get a prize when they ask questions. So is there like, was it useful? Like, yes. Yeah? Okay. So who here is? I have a question. Like, who here is actually working with Go code, like daily? Just some shy hands. Okay. So what is the interest to come to hear about Go? Is like you're planning to use it? Yeah. Cool. That's cool. Have some other questions or time to go? I'm good to go. Yeah. So I think that's it. Thank you. Yeah.